Applications using the quadratic formula. This lesson is a summary of how to set up different types of word problems. The equations to solve are quadratic. However, I have chosen problems which have equations that are not factorable. The purpose of this lesson is to give you experience in determining reasonable solutions to real-world situations. I will work 6 problems. Here is a list of the types of problem. Problem number 1 is what we refer to as a number problem. Problem number 2 is a geometry problem. Problem number 3 is a border problem. Problem number 4 is a work problem. Problem number 5 is a distance problem. And problem number 6 is a projectile problem. If you would like to fast forward to a certain type of problem, please do. It is assumed that you have some experience in solving these different types of problems. If not, and if you need to see more detail in how to solve each type of problem, then I would suggest that you view our lesson entitled Solving Word Problems with Quadratic Equations and the lesson Solving Word Problems with Fractional Equations. Both of these lessons may be checked out in the math lab. Now, let's look at problem number 1. The square of a number minus 2 times the number is 12. What is the number? Well, we refer to this as a classic number problem because what are they asking us to find? They're asking us to find the number. Well, always when we work word problems, we want to read carefully. We want to label our variable x, and in this case, x will be the number. Now, let's set up an equation. The square of a number. Well, since my number is x, the square of x would be x squared. Minus means subtract. 2 times the number would be 2x is equals 12. Now, obviously, this is a quadratic equation. All of our equations in this lesson will be quadratic. We know when we solve a quadratic equation, we want to write it in standard form. So let's subtract the 12 from both sides. We get x squared minus 2x minus 12 equals 0. Now notice that this quadratic equation has all 3 terms. The squared term, which we call the quadratic term, the x to the first power term, which we call the linear term, and the constant negative 12. When we have all 3 terms, first we try to factor, then we may complete the square or use the quadratic formula. This will not factor. It would not be that difficult to complete the square on this, but I'm going to choose to use the quadratic formula. Since it's in standard form, I know that a is the coefficient of my x squared term, which in this case would be 1. B is the coefficient of x, which is negative 2. And C is the constant, negative 12. Now we know that the quadratic formula says that our solution for this equation, x, equals minus b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. If you have not memorized this formula, I would suggest that you do. I will not write it anymore in this lesson. So if you don't know it, then you need to write it down. Substituting into the formula, we have x equals minus our negative 2 plus or minus the square root of negative 2 squared minus 4 times a, which is 1, times c, which is negative 12, all over 2 times a, which is 1. Now, we know when we get ready to simplify, we'll say minus the negative 2 is 2, plus or minus. We know that under the radical, we will first square the 2. The negative 2 squared will give us 4. We'll have minus 4 times 1 is minus 4 times a negative 12 would be a positive 48. 2 times 1 is 2. Also, we know that before we take the square root, we add these two numbers. 4 plus 48 gives us 52, all over 2. Now, at this point, it depends on what kind of an answer your teacher wants. We usually either give exact or a decimal approximation. If your teacher will accept a decimal approximation, you may go ahead and use your calculator and figure out what this is equal to. If your teacher expects an exact answer, then we need to simplify the radical and then reduce. To simplify the square root of 52, we'll think that that's the square root of 4 times the square root of 13. So we'll have 2 plus or minus the square root of 4 is 2 times the square root of 13 all over 2. Now, since we have a common factor for our 2 times the square root of 13, and our denominator of 2, we will factor that 2 out of both terms in the numerator. Remember that this is two separate terms. When we factor 2 out of 2, we're left with 1. Then we'll have plus or minus. When we factor 2 out of 2 times the square root of 13, we'll have the square root of 13 all over 2. We may now reduce our 2's. 2 divided by 2 is 1. So we get that our number is 1 plus or minus the square root of 13. Now that represents two answers. 1 plus the square root of 13, 1 minus the square root of 13. So x, let's remember what x represented. X represented our number. So x may be 1 plus the square root of 13 or 1 minus the square root of 13. Both of these would be considered exact answers. If you want a decimal approximation, then on your calculator you may say 1 plus the square root of 13, and that approximation is 4 and 61/100ths. In general, I round to 3 significant digits. The approximation for 1 minus the square root of 13 is minus 2 and 61/100ths. So it depends on which answer your teacher would prefer. Now what I would like to do is to check one of these. I'm going to choose to check the 1 minus the square root of 13. And we want to check it against the words. Okay, so we're going to check the 1 minus the square root of 13. So we're supposed to square the number. So first we'll have 1 minus the square root of 13. We want to square it. minus 2 times the number is, does that equal to 12? Well, first let's square the 1 minus the square root of 13. We will use our shortcut when we have two terms in the parentheses squared. We square the first term. Well, 1 squared is 1. For the middle term, we double the product of 1 times minus the square root of 13. 1 times minus the square root of 13 is minus the square root of 13. If we double that, we'll get minus 2 times the square root of 13. And last, we say minus the square root of 13 times minus the square root of 13, or we square this last term. Of course, minus a minus is a plus, and the square root of 13 times the square root of 13 is 13. Moving on to the minus 2 times 1 minus the square root of 13, let's distribute. Negative 2 times 1 is negative 2. Negative 2 times minus the square root of 13 would be a positive 2 times the square root of 13. And the question is, do we get 12? Well, let's see. The minus 2 times the square root of 13 and the plus 2 times the square root of 13 add to 0, don't they? 1 plus 13 is 14, and 14 subtract 2 is 12. So sure enough, we get 12. I'll leave the check of the other solution, 1 plus the square root of 13, to you. As a matter of fact, for the rest of the problems, I'll leave the check to you. But you should realize that anytime you get an answer, you should take it and check it against the words to be sure that indeed it is a solution for the problem. Now let's look at problem number 2. The base of a triangle is 2 inches more than 3 times the height. Find the base and the height if the area of the triangle is 5 square inches. Well, anytime we have a problem that talks about the area of a triangle or the area of a rectangle, I generally refer to it as a geometry problem. So this is a geometry problem. Usually we need to know a formula from our geometry. In this case, the area of the triangle, we know that area equals 1/2 times the base times the height. Now I'm going to let x equal either the base or the height, so my first decision is, what should x be? Well, the base is 2 inches more than 3 times the height. The base depends on the height, so let's let x represent the height of the triangle. And now we should be able to write an expression for the base. 2 inches more than of course means plus, so there'd be 2 plus 3 times the height would be 3 times x, or 3x. So our expression for the base of the triangle would be 2 plus 3x, and of course we want to label that. Now to set up our equation, we're going to use this formula. Area, we know what the area is, don't we? What's the area of our triangle? It's 5. So we'll replace the a with the 5. 5 equals 1/2 times the base. What was our expression for the base? Our expression is 2 plus 3x. I'm going to choose to write it as 3x plus 2, and I may do that because addition is commutative. And now I need my h. What was my h? That was my x, wasn't it? Well, on the right side of this equation, I want to reorder those factors. Let's write the 1/2 first, then the x, and then the 3x plus 2, and I may reorder the factors because multiplication is commutative. Now, what's the first thing that I want to do here? I want to get rid of that 2 in the denominator, don't I? How do I do that? Well, I need to multiply both sides of the equation by 2, don't I? So I'll have 2 times 5 equals 2 times 1/2 times x times 3x plus 2. On the left, 2 times 5 is 10 equals, on the right I have 4 factors to multiply. I have 2, 1/2, x, and 3x plus 2. I know that to do that, I will say 2 times 1/2, get the answer, multiply it times x, get the answer, and multiply that times the 3x plus 2. Well, what do I get when I say 2 times 1/2? Well, those 2's cancel and I have 1. So I've got 1 times x, which is simply x. And so then I say x times 3x, using the distributive property, I get 3x squared. And then x times 2, which is 2x. Now this is obviously a quadratic equation. I want to write it in standard form. I want to set it equal to 0. I think this would be easier if I subtracted the 10 from both sides and put the 0 on the left. So that's what I'll do. I'll have 0 equals 3x squared plus 2x minus 10. Now once again, this quadratic has all 3 terms, doesn't it? The quadratic, the linear, and the constant. I would try to factor it. It does not factor. I certainly would not complete the square on this problem because the coefficient of x squared is a number other than 1. So I will choose to use the quadratic formula. Since I have the equation set equal to 0, I may write my a, b, and c. My a, in this case, is 3. 3 is the coefficient of my x squared term. The coefficient of my x term is 2, so b is 2. And my constant is negative 10, so c is negative 10. So my x solutions would be minus b, which would be minus 2, plus or minus the square root of b squared, that would be 2 squared, minus 4 times my a, which is 3, times my c, which is negative 10, all over 2 times my a, which is 3. So I'll have minus 2 plus or minus, when I square the 2 I get 4. Negative 4 times 3 is negative 12, and negative 12 times negative 10 is a positive 120, all over 6. And of course, as usual, I always combine these two numbers before I take the square root. So I have minus 2 plus or minus the square root of 4 plus 120 would be 124 over 6. Now, I want to simplify this. If your teacher does not require an exact answer, you may go ahead and calculate this on your calculator. But for an exact answer for the square root of 124, let's think of that as the square root of 4 times the square root of 31. So we'll have our minus 2 plus or minus the square root of 4 is 2 times the square root of 31 all over 6. So I've simplified the radical. Next I see if I can reduce the fraction. I do have a common factor for my 2 terms in the numerator and for my denominator. I have a common factor of 2, so let's factor 2 out of my numerator terms. When I factor 2 out of negative 2, I have negative 1, plus or minus when I factor 2 out of 2 times the square root of 31, I'm left with the square root of 31 over 6. Dividing out common factors, 2 goes into 2 once, and 2 goes into 6 3 times. So I have as my 2 exact solutions for this equation, I have negative 1 plus the square root of 31 all over 3 and negative 1 minus the square root of 31 all over 3. Now these are both solutions of this equation, 3x squared plus 2x minus 10. However, these represent what x is equal to, and let's look at what x represents for this problem. For this problem, x is the height of a triangle. Well, if we get decimal approximations for each of these values, if we calculate on our calculator, we'll say minus 1 plus the square root of 31. We'll combine those two numbers and divide by 3. What we get is the number 1 and 52 hundredths. That's rounded to 3 significant digits. On our minus 1 minus the square root of 31 over 3, we get minus 2 and 19 hundredths, rounded to 3 significant digits. Now, if x represents the height of a triangle, we know it cannot be negative. So this solution is not valid for this physical situation. So our height we may represent as minus 1 plus the square root of 31 all over 3, and we know that that is approximately equal to 1 and 52 hundredths, and those would be inches. Now, it didn't just ask us to find the height, did it? It also asked us to find the base. So to find the base, we'll have to substitute into the expression 2 plus 3x our value for x. So we'll have 2 plus, let's go ahead and write the 3 over 1. And we want to multiply that 3 times our x, which is minus 1 plus the square root of 31 over 3. Well, of course, using our order of operations, we know we need to work out the multiplication first. So we'll have 2 plus, of course, the 3 in the numerator and the 3 in the denominator divide to 1. So we have 2 plus, and then we have minus 1 plus the square root of 31. Well, let's remove those parentheses. Plus a minus 1 will give us minus 1, and plus a positive square root of 31 will give us a positive square root of 31. Now, combining like terms, our 2 subtract 1, those are like terms. 2 subtract 1 would be 1, plus the square root of 31. And of course, 1 and the square root of 31 are not like terms. So for an exact value for our base is 1 plus the square root of 31. If you want a decimal value, 1 plus the square root of 31 is approximately equal to 6 and 57 hundredths inches. And I will leave the check to you. This would not be that difficult to check. We know that the area is 5. We know that the area is 1/2 times the base times the height. If you had a calculator, you could multiply 1 and 52 hundredths times 6 and 57 hundredths and then divide by 2, and that number should approximately be equal to 5. It won't exactly be equal to 5 because, of course, we have rounded our values for our height and base. Now let's look at problem number 3. Michael and Cannon have a rectangular swimming pool 10 feet wide and 18 feet long. They are going to build a tile border of uniform width around the pool. They have 80 square feet of tile. How wide should the border be? Well, this is a standard border problem. Sort of gives it away when it starts talking about the border, doesn't it? The other thing that is important is that you realize that when it says uniform width, that what that means is that the width of the border is the same all the way around the pool. Now I have an illustration of how we actually set up this equation. We need to physically understand what's happening. So here I have the swimming pool. We know that this dimension is 10 feet and this dimension is 18 feet, and the red represents my tile border, and of course we know it's the same width, so that means that this distance equals this distance equals this distance equals this distance. Now what would be the result if I took this outside area and I subtracted from it the pool? What would I have left? Well, I would simply have the border, wouldn't I? I would simply have the border. This outside area minus the pool would be equal to the border. So that's how I'm going to set up the equation. The area of the outside of this rectangle minus the area of the pool is equal to the area of the border. Well, by far the most difficult area to come up with is the area of this outside rectangle. So let's talk about that. What do I know? I know that this distance is 10, don't I? What about this distance? I know that that's 18. Well, what about this distance right here? Well, one of the standard things that we do when we work a border problem, when the border is of uniform width, is we let X represent the width of the border. So I know that this distance is X. Well, if this distance is X, what is this distance equal to? That is also X, right? Well, what I'm trying to figure out here is what the area of this large rectangle is. I know that to get that area, I need to take this width and I need to multiply it by this length. Do I know what this width is? Well, this distance is X, this distance is X, and what do I know that this length is? That length is 10, isn't it? So an expression for this width would be X plus 10 plus X. Now usually, since the X's are like terms, we write this as 10 plus 2x because X plus X is 2x. I'm going to label that down here on the bottom. 10 plus 2x. That's the width of this large rectangle. Now let's come up with an expression for the length of the large rectangle. Well, do I know what this distance is? Well, that distance is just the width of the border, isn't it? And what did I label as the width of the border? X. So that distance is X. Do I know what this distance is? Well, that's just the length of the pool. It's 18, isn't it? And do I know what this distance is? Well, once again, that's just the width of the border, X. So the length of this outside rectangle would be X plus 18 plus X. And of course, X plus X is 2X. So that would be 18 plus 2X. And let's label that. Now, I think we're ready to set up an equation here. how will we represent the area of this large rectangle? Well, it's length times width. What was the length here? 18 plus 2x. What was the width here? 10 plus 2x. So this expression represents the area of the large rectangle. We'll subtract from it the area of the pool. So what's the area of the pool? Well, I know that this width is 10. I know that this length is 18. So the area of this rectangle would be 18 times 10 equals, now what do I know about this border? Well, let's go back to the problem. What does it mean up here when it says they have 80 square feet of tile? That means that the area of the border is 80 square feet. So I know that this area is 80 because after all it's the border that they're going to cover with the tile. So this is my equation. I find an expression for the area of this large rectangle. I subtract from it the area of the smaller rectangle, and what that results in is the area of the border. Now let's solve this equation. First, I want to FOIL my two binomials. 18 times 10 is 180. My outside product, 18 times 2x, will be 36x. My inside product, 2x times 10, is 20x. And last, 2x times 2x is 4x squared. Minus 18 times 10 is 180 equals 80. Well, my 180 minus 180 adds to 0. Let's write the 4x squared first. Let's combine like terms. The 36x plus 20x gives me 56x equals 80. Well, since it's quadratic, let's write it in standard form. Setting it equal to 0, we need to subtract the 80 from both sides of the equation. Now, I do have all three terms of my quadratic equation. Once again, I'm going to choose to use the quadratic formula, but before I worry about my A, B, and C, I have a common factor here, don't I? Let's factor the 4 out. Let's see, I'm left with x squared. How many times does 4 go into 56? I believe it goes 14, doesn't it? So I'll have 14x minus, and 4 goes into 80 20 times. Now, as far as the 4 is concerned, actually I can ignore it. Legally, to get rid of it, I may divide both sides of the equation by 4, and of course on the left, 4 divided by 4 is 1. So I'll have x squared plus 14x minus 20 equals, and of course 0 divided by 4 is 0. Using my quadratic formula, A equals 1, B equals 14, C equals negative 20. So x equals minus b, that would be minus 14, plus or minus the square root of 14 squared minus 4 times 1 times negative 20. I'm running out of paper here. Let's rewrite this. X equals minus my b, so that's minus 14, plus or minus the square root of b squared, that would be 14 squared, minus 4 times a, which is 1, times c, which is negative 20, all over 2 times a, which is 1. So we'll have a negative 14 plus or minus. Now under the radical, we square the 14 first. We get 196. And then we'll say negative 4 times 1 is negative 4 times negative 20 is positive 80 all over 2. So I have negative 14 plus or minus. Let's add the 196 to the 80. We get 276 all over 2. Now, if you are permitted to give a decimal approximation, you may go ahead and calculate these two solutions. If you need an exact answer, then we need to simplify the square root of 276, and then we need to see if the fraction reduces. For the 276, I believe 4 goes into that evenly. Let's just divide that out. Let's see, 6 times 4 would be 24. Uh, 27 subtract 24 would be 3. Bring down the 6. 4 divides into 36 9 times. So let's see here. We'll have a minus 14 plus or minus. On the square root of 276, we'll think the square root of 4 times the square root of 69. The square root of 4 is 2. The square root of 69 is just irrational. We'll leave it like that, divided by 2. We have simplified the radical. Now our fraction will reduce because 2 goes into the negative 14. It goes into the 2 times the square root of 69 and the 2. Let's common factor a 2 out of each term in the numerator. When we factor 2 out of negative 14, we have negative 7 plus or minus. When we factor 2 out of 2 times the square root of 69, we have the square root of 69 all over 2. Of course, the 2's divide to 1, so we get minus 7 plus or minus the square root of 69. So our solutions, our exact solutions, would be minus 7 plus the square root of 69 and minus 7 minus the square root of 69. That's what we have found that x equals. Now let us remember what x represents. Where did we label x? X represents the width of the border. Now would it make any sense to have a negative width? And the answer is no, it would not. And it's pretty obvious that negative 7 subtract the square root of 69 would represent a negative number. So negative 7 subtract the square root of 69 would be an invalid answer for this physical situation. So our border, the width of our border would be negative 7 plus the square root of 69. In this case it would be feet. Let's go ahead and get the decimal approximation for that. That is approximately equal to 1 31/100 feet. So that's what the width of our border would be, 1 31/100 feet, if we want the decimal approximation, or negative 7 plus the square root of 69. Of course, that represents feet if we want the exact answer. Let's look at problem number 4. One pipe can fill a reservoir 2 hours faster than another pipe. Together, they fill the reservoir in 3 hours. how long does it take each pipe to fill the reservoir? So we want to find out how many hours it takes each pipe to fill the reservoir. This is a standard work problem, isn't it? Where we have two pipes working together to fill the reservoir. Now we know when we set up the equation, we want to set it up in terms of the amount of work done in 1 hour. However, what we first need to do is to get an expression for the number of hours it takes each pipe to fill the reservoir. So we want X to represent the number of hours that it takes one of the pipes to fill the reservoir, and that's our first decision. So let's read this. One pipe can fill a reservoir 2 hours faster than another pipe. It would seem that the time that it takes this one pipe depends on the time that it takes this other pipe. So let's choose X to represent the number of hours Now, let's look at this. If it says one pipe can fill a reservoir 2 hours faster than another pipe, this first pipe I'm going to refer to as the faster pipe, and this second pipe I'm going to refer to as the slower pipe. So X will represent the number of hours it takes the slower pipe to fill the reservoir, and of course that is to fill it working alone. Now we need an expression for the number of hours it will take the faster pipe to fill the reservoir. Now notice, if this pipe can fill the reservoir faster than this other pipe, that means that it takes this faster pipe less time to fill the reservoir than this other pipe. And how much less? Well, if it can fill the reservoir in 2 hours faster than the other pipe, then it will fill the reservoir in 2 hours less than the other pipe. So how will we express 2 hours less than X? Well, of course, it's X minus 2. So X minus 2 will be our expression for the number of hours it takes the faster pipe to fill the reservoir working alone. Now let's also denote how long it takes them working together, and it says that together they fill the reservoir in 3 hours. So 3 represents the number of hours it takes to fill the reservoir with both pipes working. Now, what we want to do then is to work on our equation, and like I said, on a work problem, we set it up in terms of how much work is done in 1 hour. Well, if it takes 3 hours to fill the reservoir with the pipes working together, how much of the reservoir is filled in 1 hour? Well, 1/3 of the reservoir would be filled in 1 hour, wouldn't it? Well, if it takes the slower pipe X hours to fill the reservoir working by itself, in 1 hour, how much of the reservoir will it have filled? Well, it will have filled 1/X. That would represent the part of the reservoir that the slower pipe can fill in 1 hour. And what would the expression be for the part of the reservoir that the faster pipe can fill in 1 hour? Well, it would be 1 over x minus 2. So we will add these two quantities together, which these quantities represent the amount of the reservoir filled by the slower pipe plus the amount of the reservoir filled by the faster pipe in 1 hour will equal to the amount of the reservoir filled by the pipes working together, which is 1/3. Now we have a fractional equation here. To solve a fractional equation, we want to get rid of the denominator. Let's find the LCD. We have a factor of x, a factor of x minus 2, and a factor of 3. So our LCD will be 3 times x minus 2. Let's multiply both sides of the equation by this LCD. And when we learned to work these work problems, we found that in this case, when we multiply both sides of the equation by the LCD, what that amounts to is to multiply each term in the equation by the LCD. So let's say 3x times x minus 2 times the 1 over x plus 3x times x minus 2 times the 1 over x minus 2 equals 3x times x minus 2 times 1/3. Now let's look at each of these terms. In this first term, of course, the x divided by x is 1. We are left with 3 times x minus 2. In the second term, the x minus 2 divided by x minus 2 is 1. We are left with 3x equals, and on the right side of the equation, 3 divided by 3 is 1. We're left with x times x minus 2. Now let's remove the parentheses. 3 times x is 3x. 3 times negative 2 is negative 6. Plus 3x equals x times x is x squared. X times negative 2 is negative 2x. Now this is a quadratic equation. Let's combine like terms on the left. 3x plus 3x gives us 6x minus 6 equals x squared minus 2x. I need to set this equal to 0. I'm going to choose to move the 6x and the minus 6. Let's subtract the 6x and add the 6 to both sides. On the left, the result is 0. On the right, we have x squared minus 8x plus 6. And of course, we have a quadratic equation. We notice that for this quadratic, on the right side, we have all 3 terms that we may have for a quadratic: the square term, the linear term, and the constant. That tells us first to try to factor. It does not factor. Next, this one would not be bad to complete the square on, because the coefficient of x squared is 1 and the coefficient of x is even. But I'm going to choose to use the quadratic formula. Since I have it set equal to 0, I can determine that a is 1, b is negative 8, and c is 6. So using my formula, I have that x equals minus b, that would be minus a negative 8, plus or minus the square root of negative 8 squared, that of course is my b squared, minus 4 times a, which is 1, times c, which is 6, all divided by 2 times a, which is 1. So, of course, minus the negative 8 is 8, plus or minus. We square the negative 8 first, following our order of operations, and then we'll say negative 4 times 1 times 6 is negative 24, divided by 2. We get 8 plus or minus. And of course we know that we combine the numbers under the radical before we simplify the radical. 64 subtract 24 will give us a 40 under the radical divided by 2. Now if we want decimal approximations, we could go ahead and compute these numbers using our calculator. If we want exact solutions, then we need to simplify the radical and then reduce the fraction. When we simplify the radical, we'll think the square root of 4 times the square root of 10. So we'll have 8 plus or minus the square root of 4 is 2 times our square root of 10 over 2. Our 8, our 2 times the square root of 10, and our 2 have a common factor of 2. Let's factor the 2 out. In our first term in the numerator, we're left with 4 plus or minus. In the second term, when we factor 2 out of 2 times the square root of 10, we're left with the square root of 10 all over 2. Since our 2's are both factors, we may divide them out, and 2 divided by 2 is 1. So we get two solutions here. We get that x is equal to 4 plus the square root of 10, and x is equal to 4 minus the square root of 10. Of course, these are exact values. Now, if we calculate, we get decimal approximations. 4 plus the square root of 10 is approximately equal to 7 16/100ths. The 4 minus the square root of 10 is approximately equal to 838 thousandths, and both of those are rounded to 3 significant digits. So these represent solutions. Of course, since we have a fractional equation, we need to check and make sure that neither of those solutions make the denominator equal to 0, and if they do not, the other thing that we need to check is, now just what exactly did x represent? Well, in this case, x represented the number of hours it takes the slower pipe to fill the reservoir. Now, our question here was, how long does it take each pipe to fill the reservoir? So we have come up with the number of hours it takes the slower pipe to fill the reservoir, and we need to find the number of hours it takes the faster pipe. And the numbers that we have are, we have 4 plus the square root of 10, which is approximately 7 16/100ths, and we have 4 minus the square root of 10, which is approximately 838 thousandths. So I want us to look at these two values. These are values for x. Now, we are saying that it takes the slower pipe 7 16/100ths hours to fill the reservoir working by itself. If we want to figure out how long it takes the faster pipe, then we have to take our x, which we may use 4 plus the square root of 10, or you may use 7.16. 7.16 would certainly be easier, and we need to subtract 2 from it because we know that the faster pipe is 2 hours faster than the slower pipe. If we need exact values, then we need to use this 4 plus the square root of 10. So I'm going to replace this x with 4 plus the square root of 10. Then I need to subtract 2 from it. Well, in this computation, the 4 subtract 2 are like terms. So I say 4 subtract 2 would be 2 plus the square root of 10. Of course, 2 and the square root of 10 are not like terms. So 4 plus the square root of 10 represents the time that it takes the slower pipe to fill the reservoir, and 2 plus the square root of 10 represents the time that it takes the faster pipe to fill the reservoir. And let's get an approximation for that. That approximation, 2 plus the square root of 10 would be approximately 5 1/1600 hours, and calculate that on your calculator, and you find this, and sure enough, when you have those decimal approximations, you can see that this time is 2 hours faster than that time. I think that's very important. So let's just label this. We know it's the time of the slower pipe, and this is the time of the faster pipe. And we got that from our solution 4 plus the square root of 10. Now look what happens when we use the solution 4 minus the square root of 10. To find how long it takes the faster pipe, if we plug 4, subtract the square root of 10 in for x, we'll have 4 minus the square root of 10, and then we have to subtract 2 from it. Once more, combining like terms, 4 subtract 2 gives me 2. I have 2 minus the square root of 10, and the square root of 10 is 3 point something, isn't it? So 2 subtract 3 point something would be a negative number. Let's go ahead and get the decimal approximation here. That would be minus 1 1/1600, and that does not make sense for this problem, does it? It would not make sense to say that the faster pipe can fill the reservoir in negative 1 1/1600 hours. So these solutions are not valid for this physical situation. So the only answers here would be, if you want exact answers, 4 plus the square root of 10 for the slower pipe, 2 plus the square root of 10 for the faster pipe. If you want decimal approximations, 7 1/1600 for the slower pipe, 5 1/1600 would be the time for the faster pipe, and of course all of those represent hours. Problem number 5. Susan hikes up an 8-mile long mountain trail. Her speed going down the trail is 1 mile per hour faster than her speed going up the trail. Susan spends a total of 6 hours on the trail. What is Susan's hiking speed up the trail, down the trail? Well, now this is a standard distance problem, isn't it? In this case, Susan has made 2 trips, one up the mountain and one down the mountain. For a distance problem, we use our distance formula. We know that distance is equal to the rate times the time. Now, very often, we like to know what the rate is or what the time is in terms of the other variables. So what I'm going to do is to solve this equation for t. Since t has been multiplied by r, to solve for t, I need to get rid of the r by dividing both sides of the equation by r. That gives me that d divided by r is equal to, and of course r divided by r, since those are factors that I can go ahead and cancel, equals t. So I'm going to use the fact that t, time, can be found by taking the distance and by dividing it by the rate. You might want to write this formula down. Now, when I work a distance problem, I set up what I call a distance chart, and for each trip, and I'll just call the trip up the mountain and the trip down the mountain, I want an expression for the distance, for the rate, and for the time. Well, let's see what we can find out. Let's read that first sentence again. Susan hikes up an 8-mile long mountain trail. Well, that means the distance up is 8, and she's going to go back down, and the distance down then will also be 8-1. All right, let's go to my rate column. Well, rate, of course, stands for this speed, and that's actually what we're trying to find here, isn't it? The question is, what is Susan's hiking speed up the trail, down the trail? Well, since that's what I'm looking for, I need to let x be my expression for her speed either up the trail or down the trail. And so that's what I need to decide. Should x represent the rate up or the rate down? And let's go back and read the sentence that tells us about the speed. Her speed going down the trail is 1 mile per hour faster than her speed going up the trail. So the speed going down the trail depends on the speed going up the trail. So x is going to represent the speed going up the trail. And let's denote that. X represents Susan's speed going up the trail. So now what I need to do is to get an expression for Susan's speed going down the trail, and let's see what information they've given me. Her speed going down the trail is 1 mile per hour faster than her speed going up the trail. Well, I deliberately worked this problem in this lesson that dealt with faster than. In problem number 4, we were talking about faster than, and we were talking in terms of time. And when we talk in terms of time, if I can do something faster than you can, then that means it takes me less time. But when we talk in terms of rate or speed, if I am going faster than you are going, then that means my speed is greater than your speed, or my speed is more than your speed. So it's very important that we understand that this expression faster than means something different when we're speaking of time and when we're speaking of a rate. In this case, we're speaking of a rate. So, since we're talking about a rate, this means her speed going down the trail is 1 greater than, or 1 more than, 1 mile per hour more than her speed going up the trail. So for the expression going down the trail for her rate, I take her speed going up the trail, and 1 more than that would be x plus 1, or 1 greater than that would be x plus 1. Now for time, I use that equation. I know time is equal to distance divided by rate. So an expression for her time going up the trail would be the distance 8 divided by the rate x. And an expression for her time going down the trail would be the distance 8 divided by her rate going down the trail, which would be x plus 1. So I have filled out my distance, rate, and time chart. Once I have that chart filled out, I need to use these expressions to write my equation. Now, in this problem, the line that helps me write the equation is the line that says Susan spends a total of 6 hours on the trail. What that means is that the time it takes her to go up the trail plus the time it takes her to go down the trail is equal to 6. Well, what was the expression for the time it takes to go up the trail? That's 8 over x, isn't it? So let's write that. 8 over x. And I want to add that to the expression for the time it takes her to go down the trail. Well, what's the expression? It is 8 over x plus 1. So I've taken the time it takes to go up, I've added it to the time it takes to go down, and I know that that is a total of 6 hours, that these two added together equals 6. Let's go ahead and write that 6 over 1 since I have denominators. Once again, I have a fractional equation, and I know that to solve it, I need to find the LCD. In this case, I have a factor of x, a factor of x plus 1, and a factor of 1. My LCD then would be x times x plus 1. So let's multiply both sides of the equation by this LCD which of course means in this case to multiply each term by this LCD. So I'll say x times x plus 1 times 8 over x plus x times x plus 1 times 8 over x plus 1 equals, and on the other side of the equation, I don't think I need that 6 written as a fraction anymore. Let's write x times x plus 1 times the 6. So, looking at the left side, of course, x divided by x is 1. I'm left with x plus 1 times 8. For this second term, x plus 1 divided by x plus 1 is 1, so I'm left with x times 8, or 8x equals. Now what I'm going to do is to rearrange these factors. I simply have 3 factors here. The commutative property will allow me to write my 6, then my x, then my x plus 1. So we've gotten rid of fractions. Next we'll get rid of parentheses. 8 times x is 8x using the distributive property. 8 times 1 is 8 plus 8x equals, and on the right side, of course, the 6 times x is just 6x, and then distributing the 6x. 6x times x is 6x squared, and 6x times 1 is 6x. So I have that quadratic term. So I have a quadratic equation. Let's combine like terms first. 8x plus 8x will give us 16x plus 8 equals 6x squared plus 6x. I need to set this equal to 0. In this case, I think it'd be easier to move the 16x and the 8. In general, I try to move my terms so that my coefficient of x squared is positive. So if I leave that 6x squared where it is, it will remain positive. Let's subtract the 8 from both sides. On the left I get 0. On the right I have 6x squared minus 10x minus 8. Now, I have a common factor on the right. Let's factor 2 out. We're left with 3x squared minus 5x minus 4. Let's get rid of the 2. Of course, the 2 is a constant factor. It's not a variable factor. So I may divide both sides of the equation by that 2. 0 divided by 2 is 0. And of course, 2 divided by 2 is 1. That leaves me with 3x squared minus 5x minus 4. So on the right side of this quadratic equation, I have all 3 terms that make up a quadratic: the squared term, the linear term, and the constant. When I have those 3 terms, I first try to factor, and this doesn't factor. Next, I could complete the square or use the quadratic formula. I would not complete the square here because the coefficient of x squared is a number other than 1, and also because the coefficient of x is not an even number. Using the formula, since I have this equation set equal to 0, I can determine my a, b, and c. My a is 3, my b is negative 5, and my c is negative 4. So my x solutions will equal minus my b minus 5 plus or minus the square root of my b squared minus 5 squared minus 4 times my a times my c all over 2 times my a. Now, minus my minus 5 gives me 5. Under that radical, the negative 5 squared is 25. The negative 4 times 3 is negative 12, and negative 12 times a negative 4 is a positive 48 over 6. So I'll have 5 plus or minus. Let's combine the 25 plus the 48. We get 73 over 6. Now the square root of 73 does not simplify, and I have no common factors for my 5, my square root of 73, and my 6. So my two x solutions that I have found here, and of course these would be exact, those x solutions would be 5 plus the square root of 73 over 6, and 5 minus the square root of 73 over 6. Now let's remember what x represents. X represents the rate or the speed that Susan went as she was hiking up the mountain. Well, let's look at this. This 5 minus the square root of 73. The square root of 73 is a number between 8 and 9, isn't it? And 5 subtract 8 point something is going to give us a negative numerator divided by a positive denominator, which would result in a negative speed. We don't think of speed in terms of negative, so this would not be a valid speed for Susan to be hiking up the mountain. So our only valid solution for her speed up the mountain would be 5 plus the square root of 73 over 6. That represents the exact value. Let's go ahead and write down what the decimal approximation is. In case some of you need that decimal approximation, it would be 2 26 hundredths. Now this represents her speed, which would be miles per hour, and we know that from the original words of the problem when it refers to her speed. Says her speed going down the trail is 1 mile per hour faster than her speed going up the trail. So that tells us that our speed is being measured in miles per hour. So what we have here is her speed going up the trail, is 2 26 hundredths miles per hour. We also need to get her speed going down the trail. So since 5 plus the square root of 73 over 6 represents x, to figure out her speed going down the trail, let's take our x and we need to add 1 to it because we know it's 1 mile per hour more. Well, when I get ready to add 1 here, since this is a fraction, let's write 1 in its fraction form with the denominator 6, which would be 6 over 6. When I add these two fractions, of course the denominator stays 6. What I have is 5 plus the square root of 73 plus 6. Well, the 5 and the 6 are like terms, so I'll say 5 plus 6 is 11 plus the square root of 73, all divided by 6. Now that represents the exact speed that she was going down the trail. If we want a decimal approximation, then we can calculate that, and we will get 3 26, and of course that is miles per hour. That's 3 26 hundredths miles per hour is her speed going down the trail. And please notice that sure enough, her speed going down is 1 mile per hour faster than her speed going up, and I think those decimal approximations show that very well, don't they? Of course, the other thing that we need to be concerned about that I sort of overlooked here was for these two solutions did they make either of these denominators equal to 0? And of course the answer is x would have to be 0 or x would have to be -1, and neither one of these is 0 or -1. So there's not really a problem with these solutions being solutions for this fractional equation. The only problem is that this solution is not a solution for our word problem because her speed going up the mountain would not be negative. Problem number 6. Well, just looking at it, we can see we have an equation there. That's kind of nice, isn't it? It says a cannonball is fired upward from a 120-foot tall cliff with a speed of 112 feet per second. The equation that gives the cannonball's height above ground level is h equals -16t squared plus 112t plus 120. The question is, when does the cannonball hit the ground? Well, I'll address this question in just a minute. First, let's be sure we understand what this equation represents. The h stands for height, t stands for time. When they tell us that the speed is 112 feet per second, that tells us that the height is measured in feet and that our time is measured in seconds. And what this equation gives us is a way to find the height of the cannonball for a given time. As an example, if t equals 1 second, if we want to see how high above ground level the cannonball is after it has been fired for 1 second, then what we do is we substitute 1 in for these t's. So h, our height, equals -16 times 1 squared, substituting the 1 in for the t, plus 112 times 1 plus 120. Now let's figure out what number this is equal to following our order of operations. We know we square first. 1 squared is 1. Then we may multiply. -16 times 1 is -16, plus 112 times 1 is 112, plus the 120. Combining these numbers, we'll get -16 plus 112 is 96. Adding the 96 to 120, we get 216. What this means is, after the cannonball is fired for 1 second, the height after the cannon is fired and the cannonball has been traveling for 1 second, the height of the cannonball is 216 feet. If we wanted to find the height at 2 seconds, then we'd put a 2 in where we put the 1s. At 3 seconds, we could replace the t's with 3, and so on and so forth. That's not the question, though, is it? The question is, when does the cannonball hit the ground? Well, when refers to time. At what time does the cannonball hit the ground? Well, when the ball hits the ground, what is h equal to? What is the height when it's on the ground? Well, the height is 0, isn't it? So really, when they give us this question, when does the cannonball hit the ground, what that means is find t when h is 0. That's what they're asking us to do. We want t represents the time when, and when the cannonball hits the ground, the height is 0. So the way we do that is to replace this h with 0, and then look what we have. We have a quadratic equation, don't we? So we may solve it for t. Now, of course, since I have the quadratic term, the linear term, and the constant, that suggests to me that I could try to factor it. I don't believe I try to factor this one anyway, because the numbers are so large. Let's use the quadratic formula on it, and I do have a common factor. And the other thing about this problem is I have a negative coefficient of my t squared. Whenever I have a negative coefficient of my t squared, I go ahead and factor a negative out of each of the three terms, in this case on the right side of this equation. But I can take more than a negative out. I believe 8 is a common factor also. So let's factor negative 8 out. When I factor negative 8 out of negative 16t squared, I'm left with a positive 2t squared. When I factor negative 8 out of 112t, let's see, 112 divided by negative 8 would leave me with a negative, and how many times does 8 go into 112? I believe it goes 14. So I'll have negative 14t, and factoring negative 8 out of 120, of course, the positive divided by the negative is a negative, and when I divide 8 into 120, I get 15, don't I? Once again, I may divide both sides by that negative 8 to get rid of it. 0 divided by negative 8 is 0, and of course negative 8 divided by negative 8 is 1. Anytime I have a common factor on this case, the right side of the equation, if that common factor is a constant, then I may get rid of it by dividing both sides by that common factor. I am left with 2t squared minus 14t minus 15. Now, to solve this using the quadratic formula, my a is equal to 2, my b is equal to negative 14, my c is equal to negative 15. My t solutions will equal minus b, so that would be minus a negative 14, plus or minus the square root of negative 14 squared, that's my b squared, minus 4 times my a times my c, all divided by 2 times my a. Well, of course, minus the negative 14 gives me 14. Under that radical, let's square that negative 14. When I square that negative 14, I get 196. And now negative 4 times 2 will give me negative 8. Negative 8 times negative 15 will give me positive 120. All divided by 2 times 2, which is 4. Let's add those numbers under the radical. We'll have 14 plus or minus the square root of, let's see, 6 plus 0 would be 6, 9 plus 2 would give me 11, and 1 plus 1 plus 1 would give me 3. I need to simplify that square root of 316. I believe 4 will go into 316 79 times, won't it? So I think square root of 4 times square root of 79, square root of 4 is 2, and I cannot simplify the square root of 79. Once again, I have a common factor for my two terms in the numerator, and my denominator have a common factor of 2. So let's factor the 2 out. When I factor 2 out of 14, I'm left with 7. Plus or minus, when I factor 2 out of 2 times the square root of 79, I'm left with the square root of 79 all over 4. Since the 2 and the 4 are factors, I can reduce here. 2 goes into 2 once and into 4 twice. So I get 7 plus or minus the square root of 79 over 2. Now those are my t values. So I have found that I have a time of 7 plus the square root of 79 over 2 and a time of 7 minus the square root of 79 over 2. Now we need to check to see if these are valid answers. Of course, t represents the time that the cannonball hit the ground. What about this second solution? What about the square root of 79? That's a number between 8 and 9, isn't it? And if I say 7 subtract 8 point something, then my numerator is negative, and of course a negative number divided by a positive number would give me a negative result. So this would represent negative time, and for this cannonball we don't think of it in terms of having negative time. It begins to travel at time equal to 0 and only moves forward in time. So the only valid solution here would be 7 plus the square root of 79 over 2. Let's get a decimal approximation for that. The decimal approximation for that is 7 and 94/100ths. Of course, to get the decimal approximation, we calculate. We say 7 plus the square root of 79. We combine those two numbers, and then we divide that result by 2. So when we do rounding to 3 significant digits, we get 7 and 94/100ths. Now t was in seconds, so what that means is that it takes this cannonball that was fired from that cliff almost 8 seconds to reach the ground. It takes 7 and 94/100ths seconds to reach the ground. This completes the applications using the quadratic formula lesson. Please rewind the tape before you return it. Thank you.